Hi everyone, today we will look at an interesting geometry problem which I composed with a friend. So we have a triangle ABC which is non-equilateral. R is the radius of the circle and let S be the perimeter of triangle ABC. We have to prove that at least one of sine A times cos B plus cos C, or sine B times cos A plus cos C, or sine C times cos A plus cos B is larger than S over 6R. There are a lot of advanced problem-solving skills and logical reasoning involved in this problem, so make sure you stick around for the solution. Firstly, allow me to introduce a high-level method of logical reasoning. It is called the proof by contradiction. So in this classical method of proof, we first assume the counterstatement, which is the opposite of the statement, is true. And we try to prove that the assumption would lead to a contradiction, thereby proving the original statement is indeed correct. We will look at how this could be used to solve the above problem. So now let's dive into the actual solution to the question. So firstly, let's write down for the sake of contradiction, and then we can label these three expressions as numbers 1, 2, and 3. So we can assume that all of the expressions here are smaller than S over 6R. And this would be our counter statement. So we can add up these three expressions and we're going to have an inequality. So the sum of these three expressions would be smaller than S over 2R. So we can start working from the left-hand side. And I'll just copy the expressions once, so it's going to be easier for us while we continue working on the problem. So next we can simply expand this, and we're going to have something that looks like this. So as you can see here, I can group sine A cos B and sine B cos A together, and I can do the same to the remaining terms. So by using the compound angle formula, we can rewrite this into sine A plus B plus sine A plus C plus sine B plus C. So another thing we can observe is that the sum of all the interior angles of a triangle equal to 180 degrees. So I can rewrite this as well. So our expression would look something like this. Then we can use the compound angle formula again, and we can rewrite this as so plus sine 180 degrees times cos B minus cos 180 degrees times sine B. And then we're going to add sine 180 degrees times cos A and minus sine A times cos 180 degrees. And as we all know, sine of 180 degrees would equal to 0 and cos 180 degrees is negative 1. So we can plug that into our expression. So this is negative 1, and negative 1. And then we can simply rewrite this into sine A plus sine B plus sine C. So by using the sine law, we know that the sine of an angle equals its opposite side over 2 times the radius of the circumscribed circle. So obviously, the sum of all the three sides of the triangle is simply its perimeter. So we know that the left-hand side equals to S over 2R. However, if you guys still remember, we actually assumed that the left-hand side is smaller than S over 2R, which is obviously not the case, as we have proven that the left-hand side equals to S over 2R. So there's an obvious contradiction, and therefore we can come to a conclusion that among the three expressions, there's at least one expression that is larger than S over 2R. So another way of looking at this is that we have proven that the sum of the three given expressions is equal to S over 2R. And this is universal for all triangles. However, we have also proven that these three expressions cannot simultaneously be smaller than S over 6R. So if it was an equilateral triangle, all three expressions would equal to S over 6R, and the sum of them would still be S over 2R. But since the question already stated that it is non-equilateral, we know that the three expressions cannot all be equal to one another. And so therefore we can come up with the conclusion that at least one of them is larger than S over 2R. So thank you so much for watching this video. I hope you find this question really interesting and enjoyed it as much as we do. And please leave a like if you feel like it. And I will see you in the next video if there is one.